Good morning, students. We were discussing the hybridization concepts and Vespar theory. Okay, so in what information does hybridization give? Means if you know the type of hybridization, then we will come to know what is the geometry or shape of the molecule, and we also come to know what will be the bond angles. If you know the type of hybridization, one will come to know what is the geometry or shape of the molecule and what will be the bond angle. This we have learned already in our previous classes. So for example, if the hybridization is sp2, okay, then geometry of the molecule or the shape of the molecule is planar triangular. Planar triangular, and the bond angle is 120. So this is the example. Suppose the hybridization is sp3, then the geometry is tetrahedral and the bond angle is 109.5. So this is how one will come to know the geometry or shape of the molecules as well as the bond angles if you know the type of hybridations. This I have discussed in the previous classes. Okay, and you also remember that this bond angle as well as this geometry you will expect if the molecule consists of only bond pair of electrons. Only one pair of electrons. If a molecule has only one pair of electrons, then definitely you can expect 120 bond angle and planar triangular shape if the hybridization is sp2. So this is called the regular geometries. Regular geometry. You will expect regular geometry. You will expect regular geometries. Okay, if the molecule involves only one pair of electrons. What do you mean by one pair of electrons? The electron pair which is involved in the formation of bond is called bond pair of electrons. Bond pair of electrons. In some cases, if the molecule consists of bond pair of electrons plus lone pair of electrons. Lone pair of electrons. There are both types of electrons. Bond pair of electrons as well as lone pair of electrons. In such cases, the geometry is slightly disturbed. The bond angle is slightly decreased, even though the hybridization is sp2 or sp3. For example, I will give you in ammonia molecule, the hybridization is sp3. The hybridization involved is sp3. But if the hybridization is sp3, what geometry you will expect? You will expect the geometry as tetrahedral. And what bond angle you will expect? 109.5. Okay. Since ammonia molecule involves sp3 hybridization, you will expect tetrahedral as its geometry and 109.5 as its bond angle. But in reality, it is found that the geometry of ammonia is not tetrahedral, it is pyramidal. It is pyramidal structure and the bond angle in ammonia is 107 degrees. So the bond angle is decreased here and the shape is also not tetrahedral but it is pyramidal even though the hydrogen is sp3. Why? What the reason is in ammonia there are both one pair of electrons as well as lone pair of electrons. So because of the presence of lone pair of electrons, the ammonia molecule has slightly distorted tetrahedral shape. That distorted tetrahedral shape is called pyramidal shape and also its bond angle has decreased from 109.5 to 107 degrees. This geometry is called the irregular geometry. Irregular geometry. Expected shape bandre regular geometry, unexpected shape bandre irregular geometry. Expected shape yadu, if the hydration is sp3, what is the expected shape or what is the expected geometry? The expected geometry is tetrahedral. But in this case, though the hydration is sp3, okay, but still the shape is pyramidal. So such type of geometries are called irregular geometries. So irregular geometry is due to the presence of lone pair of electrons in the molecules. What do you mean by lone pair of electrons? This pair of electrons do not take part in the bond formations. Do not take part in the bond formation. The electron pair which takes part in bond formation is called bond pair electrons. Bond pair of electrons. Similarly, the electron pair which do not take part in bond formation is called lone pair of electrons. Okay. And according to this theory, the repulsion between lone pair electrons is greater than lone pair electrons, which is greater than bond pair electrons. So this is the sequence. Okay, if a molecule contains two lone pair of electrons, then the repulsion is high. Repulsion between this pair of electrons is high. When the repulsion is high, the bond angle decreases. So, whenever there is more and more repulsion in such molecules, the bond angles goes on decreasing, and this is the condition according to Westphal theory. And in the last class, based on this, I have given so many examples, and today let me give some more examples of ions. Hybridization in some ions. I shall take up the BF4 minus ion. BF4 minus ion. So again, the first step is select the central atom. This is the first step, whether it is a molecule or ion. Okay, if you want to discuss the hybridization concepts, first you should select the central atom. In this case, it is boron. Here in this example, it is boron. Next, write its electron configuration. Okay, so we know that B is 5. The atomic number of boron is 5 and the electron 1s2, 2s2, 2p1. This is the electronic configuration which is in ground state configuration. So if you write in form of boxes, this is 2s2, this is 2p1, 2s2, 2p1. Okay, this is the ground state configuration. Now, you just see here how many unpaired electrons are here. Only one unpaired. This is the paired electron. This is the paired electron. This is the unpaired electron. But you just see in this ion there are 4 F atoms. Out of 4 F, 3 F are atoms and 1 F is ion. 3 F are atoms and 1 F is the ion, F minus ion. Okay. So totally 4. So I want 4 orbitals here. I want 4 orbitals to accommodate the electrons given by this 4f atoms. I want 4 unpaired electrons. 4 unpaired electrons. So you just consider the excited state. If you consider the excited state, so 2s electron is promoted to 2p. One electron calcium. Now we have 3 unpaired electrons. 3 unpaired electrons. Okay, this is called excited state. Now all these 3 orbitals will undergo hybridization and you get 4 sp3 hybrid orbitals. This is 1 sp3, 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 sp3. So you will get 4 sp3 hybrid orbitals. Okay, and this sp3 contains 1 electron, this contains another electron, this contains another electron, and this hybrid orbital is empty. It is empty. Okay, how do you get sp3? I told you 1 2s, 1 2s, this is 2s, is combining with 3 2p's. 1 2s is combining with 1 2 3 2p's. Yes. 3 2p's. So what are we getting here? S1 P3. Okay. Therefore, it is the sp3 hybridization. sp3 hybridization. Now you just see here one of the fluorine atom. Out of 3 fluorine atoms, 1 atom will donate 1 electron. This is the electron donated by fluorine atom. Next, another fluorine atom donates 1 more electron. 1 more electron. And another fluorine atom donates 1 more electron. 1 more electron. So all 3 fluorine atoms are over. Now we are left with 1 F minus ion. 1 F minus ion. I already told you F will do 1 electron. F atom can do 1 electron. Since it is minus ion, it will have additional electron. It will have additional electron. So totally we have 2 electrons. 2 electrons. We have 1 unpaired electron in fluorine atom. ಯಾವುದೇ fluorine atom ತಗೊಂಡ್ರೆ 1 unpaired electron ಇರುತ್ತೆ ಅದರಲ್ಲಿ. Okay, but we don't have fluorine atom here. We have F minus ion. The example is BF4 minus. Since the ion carries a negative charge, we have 1 extra electron. So totally we have 2 electrons from this F minus. So these 2 electrons of F minus will come and join. So this is the electron pair donated by F minus. This is by 1 F atom. This is another by another F atom. This is another F atom. 3 F atoms. 1 2 3 F atoms and this electron pair is given by F minus ion, and like this you will get Bf4 minus ion. So Bf4 minus ion involves sp3 hybridization, sp3 hybridization, and you just see here. You just see all are one pair of electrons only. This is one pair, and one pair. Since all are one pair of electrons, the molecule has a regular geometry, which is in this case, which is a tetrahedral with bond angle and not 9.7 of. Okay, so this is the explanation for Bf4 minus ions. This ion involves only one pair of electrons. Okay, since all electrons are one pair, the molecule has regular geometry. So what do you mean by regular geometry? Since the hybridization is sp3, the regular geometry for the sp3 hybridization is tetrahedral, and the bond angle also is equal to 109.5. So this is the explanation for Bf4 minus ions. Similar explanation is given for NO3 minus ion. NO3 minus ion. So we just see here. Again, we select the central atom. The central atom is nitrogen with atomic number 7. To write its configuration 1s2, 3s2, 2p3. This is the ground state configuration. So you write in the form of boxes. This is 2s2. This is 2p2. 1, 2, 3. 2p3. Okay. This is 2s. This is 2p. Now just see here. How many oxygen atoms are here? Out of O3s, 2 are oxygen atoms. We have 2 oxygen atoms and O minus ion. Out of 3, 2 are oxygen atoms and 1 is O minus ion. O minus ion. These 2 oxygen atoms gives 1 electron. One oxygen atom will give 1 electron, another oxygen atom will give 1 electron. But in case of O minus ion, it will give 2 electrons. 2 electrons. Understood? Out of 3 here, 3 O's, 2 O's are atoms. They are atoms. Each atom will give 1 electron. Each atom will give 1 electron to nitrogen. Whereas another O, which is in ionic form, which is a negative ion here, it will have 2 electrons. Since it carries minus charge and negative charge, it will have 1 additional electron. Therefore, it has 2 electrons. 1 electron is due to oxygen atom and 1 electron is due to negative charge. Totally, O minus carries 2 electrons. 2 electrons. Okay, now what happens is, next, out of these three, one is forced to pair up. Out of 3 unpaired electrons, one is forced to pair up. So let me write here. Okay. Now you write here. Here, right. This is the nitrogen atom configuration. Now we write oxygen atom. So oxygen atom is -2, 2s2, 2p4. This is 2s2, this is 2p4. This is 2p4. Okay, this is for one oxygen atom. So that I will write here. One day I am taking this one. Okay, fine. This is for the oxygen atom. This is for the another oxygen atom. This is for the first oxygen atom. This is for the another oxygen atom. Now and one extra electron is here. This is for O minus ion. O minus ion. So this is I have written. This is the electronic configuration of nitrogen atom. This is the electronic configuration of oxygen atom. Another oxygen atom and O minus ion. We have three. So in NO3 minus, we have two oxygen atoms and one O minus ion. This is the central atom, nitrogen atom. Now you just see how many it will give. So this will give 2 electrons here. Okay, and this will give 2 electrons. Actually, I want only one electron. So this atom gives 1 electron. This electron is forced to pair here, and now this electron can join here. This electron can join here, and this electron can join here. And like this, you will get NO3 minus ion. Okay? This unpaired electron of oxygen atom combines with the unpaired electron of nitrogen atom and forms one bond. Next, this unpaired electron of oxygen atom combines with another unpaired electron of nitrogen and forms this bond. Similarly, this unpaired electron of O minus ion combines with this unpaired electron of nitrogen atom and forms another bond. So like this, you will get NO3 minus ion, and this electron pair can combine with this empty orbital of oxygen atom. Empty orbital of oxygen atom. So this is the explanation for the formation of NO3 minus ion. Okay. In the first step, I shall repeat it. First you write the electronic configuration of nitrogen atoms, 2 oxygen atoms and 1 O minus ion. In this oxygen atom, this unpaired electron is forced to pair with this oxygen atom. Okay? And you will get the empty orbital. Here we have 2 unpaired electrons. Here we have 1 unpaired electrons. Now, this electron pair from nitrogen atom combines with this empty orbital of oxygen atom and forms a bond. Similarly, this unpaired electron of nitrogen atom combines with the unpaired electron of this O minus ion and forms a bond. Then this unpaired electron combines with this unpaired electron of nitrogen forms a bond. Okay, and then this unpaired electron of oxygen combines with this unpaired electron of nitrogen atom and forms bond. And here again you can see the hybridization is sp3 only, sp3, okay, sp3, and therefore the expected geometry is tetrahedral. The expected geometry is tetrahedral, but since it consists of one lone pair of electrons, this tetrahedral geometry is slightly distorted. This distortion is due to the presence of lone pair of electrons. Okay. Since the tetrahedral geometry is distorted, the bond angle also decreases from 109.5 to some 106 like that. So this is about the explanation for nitrate ions. So today I have given the explanation for 2 ions, BF4 minus ion and NO3 minus ion. It involves sp3, it involves sp3, but here all are one pair, so it has the regular geometry known, namely tetrahedral, whereas it has one lone pair of electrons. Therefore, it has irregular geometry, that means distorted tetrahedral shape with less bond angle. So this is brief about the hybridization concepts of ions. I have selected 2 ions. So similarly, so many examples are there, and for any clarifications, you can directly meet me or you can call me. You can meet me directly or you can call me at 991-6353-996. So you can call me, just tell your name and tell your class, and then you ask me whatever doubts you have on this phone number, or you can put a message on this number as WhatsApp message regarding your doubts. Okay, please don't neglect these topics, because it's one of the important topics in chemistry. And if you have any doubts, if you want clarification any doubts, you can directly meet me, or you can call me at this number, or you can message me WhatsApp message on this number with your doubts, mentioning your names and class. Okay, thank you.